Hello everyone, Azure Innovators Hub 2025, session day 4. We have another set of 4 sessions for today. Thank you everyone for joining this 4 days event series. I have to admit it's not easy to be the host of such a long event. And on the other hand, I'm very excited because I had to meet a lot of interesting people with expertise, with knowledge to the field, and I did learn a lot. More sessions are coming off for today, so let's give a moment to our speaker to connect, and we will be right here with you. Thank you, everyone. Well, it's time to start. We have with us our first speaker. Let me see if I can pronounce correct the name. It is Mohammed Abdul Alim Taj. Taj, is that correct? Hello, my friend.
Absolutely
How are
correct.
you?
Hi, how are you?
Nice to meet you, my friend, and welcome to Azure Innovators. Where are you calling from?
I'm calling from Texas, United States.
Texas. Oh, that's great. You live in the US?
Yes, yes, I do.
Oh, that's great, my friend. That's great. Thank you so much for joining us and submitting your session. We are so lucky to have with you to have us with us. So it's about securing global data center modernization, right? With ISO 27001. This is very important topic, right? And it's very
Correct,
hot topic for organizations these days.
correct.
How long is going your session to last? Any idea?
Probably 30, 40
30,
minutes.
30, 40 minutes. Great. So you can share your screen and I will add you to the stream and then you're in
Okay,
the driver's seat.
sure. I just give me 1 second. I just wanted to change
Absolutely. No problem.
background. Okay. Hmm.
Perfect.
Apologies. This is my first public presentation. So, yeah. Just 1 second. I'm trying to
Let me do
share
that also.
my
Yeah, no worries. Let me know if you need any help.
just I'm trying to share my screen. Are you able
Okay,
to
great.
see it?
Great. I can see it. I added in in the screen. You're good to go, my friend. Everybody, Alim, Muhammad Abdul Alim with us, Taj, you're driving.
All right. So let me know when this session is started, and then I will
Yes,
take it
we
forward.
are live.
Sorry.
We are live. You can start.
All right. Okay. Uh, Thank you so much. Good morning, everyone. Good morning, good afternoon, good evening. Um, Thank you so much for joining today. I'm happy to be here at the Azure Innovators Hub conference to talk about securing global data center modernization and ISO 27001 aligned architectures. Before I start with the main content, I would like to share a little bit about my background. I've been working in infrastructure and cybersecurity over the 20 years. I had an opportunity to work with different part of the world, EMEA region, United States and India. Over these years, I have managed and delivered many data center projects, including the migration, modernization, transformation, decommission activity. I have worked. The project which I have delivered is converting the primary data center to DR and DR data center to primary, converting the data center to branch office, and decommissioning of the data center. Those are the project and program I have delivered in terms of data center work stream, and connecting global offices to the central headquarter data center over the SD-WAN using Cisco Meraki solution and Riverware WAN optimization solution. Um, I have led ISO 27001 project and program in the past, both as a enterprise architect as well as a senior technical project and program. So uh, when it comes to the ISO, I have both the uh, strength, which is the technical and project and program management. So I personally have implemented so many ISO controls. In the past, I have vast experience in delivering the ISO 27001. This is something I have delivered for $250 billion company. That is one of the biggest organization in the EMEA region. Um, since I've been working with the data center transformation initiatives, so I have experience working with the managed data center provider, for example, Equinix, Cyrus1, a couple of other service provider in the EMEA region. So I'm very well versed what kind of process they follow when it comes to the data center operation and connectivity and all those stuff. So mm, that is also something we gonna discuss. The In the data center space, there are a lot of technical aspect, not only about the information security control, but at the data center level, having the race floor, electrical, mechanical systems, UPS systems, the power consumption, air condition, and mechanical systems. So these are the solution or the control which I have very well versed. And again, my goal today is to share the lessons and example from my real projects and with my real experience. So the at the end of the session, I hope you will see the modernization is not just the technology; it all about building a secure, reliable, and future-ready foundation, which helps the organization grow with confidence. All right. Uh, Now let's move forward with the agenda. Um, we will be talking about the enterprise modernization challenge. Currently, organization they wanted to modernize their infrastructure at any cost, but there are a lot of challenges on that. The only when it comes to the modernization, we have on-prem infrastructure, we have cloud infrastructure, and we have the hybrid infrastructure. So in order to modernize that, we need to have a framework um, uh, which can enable the modernization not only the on-prem infrastructure, at the same time at the on the cloud and on-prem infrastructure as well. That's the key for any organization. The major challenge here in the enterprise modernization, we need to make sure that whether the organization is aligned with the modernization. Are they ready to move forward? Are their vision and strategy is aligned with the modernization approach? That's the key when you go, and that's the major challenge we face. We as an IT infrastructure, as an architect, we try to modernize the infrastructure, but we realize that down the line we realize the leadership and the organization strategies going towards different direction. So that's the major challenge to make sure that the leadership and organization is aligned with the modernization approach. That's where we need to make sure that we address those challenges. Once we have the leadership aligned with us in terms of modernization, the other challenge we have is the budget constraint. Most of the time, what I've seen, major project and program, we start the modernization journey, and then over the period of time, there are a lot of changes, org restructure, merger and acquisition. We tend to lose the budget somewhere down the line, and then since the organization change, their direction also will get changed, or the priorities will get changed. So making sure that we have the budget in place and cover all the risk in the program in terms of org changes and all those stuff. So other than that, we have seen that technical expertise, architects, technical SMEs, not only within the region, we need to see when it comes to the data center, you will, most of the scenario, you will have geographical uh, distributed data center. So we need to see we have all the skilled resources to modernize our infrastructure. And sometimes what we generally happen is that we do it at the very within the region, but we don't focus about the other region where we need the implementation partner, vendor, and skill set at the implementation partner level, right? So we cannot have our IT infrastructure presence in each and every location. For example, if my headquarter in US and I'm building the data center, and my other data center which I'm provisioning in London, Brazil, India, China. So we need to make sure the political impact, geographical political impact, whether we have the resource and implementation partner. So that's also another challenge we generally face in enterprise modernization. And even then, if we cover all those challenges, the other challenge is that we tend to modernize the infrastructure, but we need to make sure that the business continuity is there. We should not impact our day-to-day operations. We should not impact our user experience. We should not impact our client and customer. And at the same time, make sure that the modernization is taken care, and then we have the modern infrastructure. Those are the major challenges we face in the modernization space. A decade of transformation and excellence, like my team, we have done multiple data center transformation, as I mentioned earlier, building the new data center from the scratch, raised floor, structured cabling, rack layouts, mechanical and electrical systems, power consumption, data center environmental monitoring systems, which will monitor the dust, fire, water, and all those stuff. So those are the key in terms of monitoring the data center. So we have that excellence, and generally the way we do it, when we provision the data center or we migrate the data center, we make sure that we follow the ISO 27001 controls to make sure that the controls are there from day one, and we have the comprehensive security framework integrated in every data center implementation, migration, and decommission approach. That's the key. In terms of decommission, we make sure that once we decommission the assets and everything, we make sure that it's completely wiped out. We have the e-waste management process. We have the destruction certificate from the third party and everything. So those are the other controls when it comes to decommission. Decommissioning is more critical than implementing any data center. So where we generally lose that interest when it comes to decommissioning. The scale of migration, what we have done is the petabyte scale of data movement, whether it's merger and acquisition, migrating the data, making sure that the user experience is taken care, and we have minimal business disruption. ISO 27001 Foundation, of course, this is the key piece when it comes to the for any organization. When it comes to the ISO 27001, this is the backbone of the infrastructure. We wanted to first, when we build this ISO 27001, we wanted to make sure that the business is aligned with that. Other than the business where we have to implement 93 controls, which is directly aligned with the architectural design, migration, planning, and operation procedure. These controls, earlier it is more than 100, if I'm not mistaken, 143 controls. Now it reduced to 93 controls. In order to implement these controls, we need to have the collaboration and buy-in from all cross-functional team, HR, procurement, facilities, uh, uh, the other compliance and legal team. All those teams needs to be aligned, and they should go towards this approach. And at the same time, they need to have the resources to handle these controls, to implement this control during the implementation project life cycle or program life cycle. And after, when we deliver these, then we need to make sure that we have those controls, the resources are aligned to maintain and for the operational activity. uh, mm, so when it comes to the NetOps team, we need to have the network resource who can implement all these network security related component. When it comes to the cloud, we need to have the cloud resources, and virtual infrastructure resources. So making sure that the direction is one thing, that yeah, we wanted to achieve this ISO 27001. And why we wanted to achieve, because we wanted to have that reputation in the market. We wanted to showcase to our clients and customers that yeah, we give utmost priority to security. And that's the message we want to pass. But at the same time, when you implement these controls, the processes will make your day-to-day operation so smooth, and at the same time you have all the processes, all the artifacts and control in place. When it comes to the audit and internal and external audit, you will have all the artifacts which will make sure that we have all the clearance from internal and external audit. So that's the key. There are multiple, as I mentioned, 93 controls are there, but I will focus on very few controls in the interest of time. The information security policies, these are the policies which we need to prepare and make sure that each and every employee in the organization is adhered to these information security policies. It might be very basic, for example, clear desktop policy. Make sure that your desk is clear. There is no confidential document or data is there, or any confidential data is presented at the desktop, whether it is password or some key keywords or something. So make sure that is in place, um, and all those information security policies, the password usage policy, acceptance user use policy, um, data classification and handling policy. How do we classify the data when you share the data with the internal within the team? What kind of data tagging we need to use? Internal, public, confidential. So those kind of data classification, we need to have the policy and we need to have the control in place. We generally use Titus data classification solution. There are a lot of solution in the market. There are two things, is that when you implement this policy, there are data which is already at rest. How do we assign the tagging, data classification? Of course, when you have the new data, then it will be easier for you whether you are sending an email, tag it with the data classification and everything. When you prepare any document or anything, then you will have the classification and everything. But how do we implement the data which is already there, reside in the organization? So that's another challenge we face, and then we cover that. Incident responses. How do we respond to the incident? What kind of process has to be in place? Uh, And change management policy. How do we present the change in the CAB board meeting, change advisory board meeting? I was one of the CAB advisory board member who is validating the change service ticket, and making sure that we have all the information is in place. When it comes to the change, do we have the pre and post implementation artifacts? Do we have a rollback policy and all those stuff? So those kind of controls will make sure that it is documented, and at the same time, when it comes to the real time experience, we'll make sure that that is in place. Access control, zero trust architecture. Yes, of course. When it comes to the security, earlier we never used to focus on zero trust, but now each and every enterprise organization is going towards the zero trust architecture. So we enforce that least privilege principle at every level, whether it is application level, document level, SharePoint, Teams, everywhere. We implemented single sign-on. We implement MFA, multi-factor authentication. There are multiple tools, RSA. There is a new product, Silverford, which we use. Silverford is something when you deploy on the Active Directory, you don't need to deploy the same agent across all the servers or desktop. So every authentication go through the domain controller. So those kind of solution, innovative solution, it will reduce the number of uh, the tokens and licenses. That is something we generally use. Um, in terms of cryptography controls, yes, we use Venafi zero trust PKI solution, IPX solution, which will take care of your PKI infrastructure. It is the orchestration solution for all your PKI solutions. So you submit the request, we integrate this IPX and Venafi zero touch PKI. Venafi is now acquired by CyberArk. So we integrate with the ITISM tool like ServiceNow, submit the ticket and making sure that all tickets are approved. We follow the approval process. Once it is approved, the certificate will get generated automatically. That is the lifecycle management. So, and there are a couple of other end-to-end encryption tool we use, such as Symantec, McAfee. We use DLP solution as well, which will provide the encryption at rest as well. Let's move forward with the topic, the enterprise grade technology stack. If you know, in the traditional data center, we used to have multiple rack servers, blade servers, and so many other infrastructures. Now we move towards the virtualization solution, then we reduce the footprint of the physical hardware into from 1,000 to hundreds and all of ESXi host or Hyper-V host. Now with the hyperconverged infrastructure, even those ESXi hosts or all those stuff, those are getting reduced into some 10, 20 physical servers. There are the industry best solutions are available in the market: Cisco Hyperflex, Nutanix, Dell S2D, Hyperflex, Pure Storage. Those are the hyperconverged solution where you have the hardware, you have the SAN switches, you have the network switch, everything. So it comes with the unified compute storage and networking. On top of that, it will optimize the performance, and it will simplify your day-to-day operation. It is scalable and flexible for software-defined architecture. So we're gonna discuss about the software-defined architecture in the upcoming slide. But yeah, that's the other enterprise-grade technology stack we use. From security and network perspective, Palo Alto next generation firewall. In the Palo Alto, you have multiple subscriptions like DLP, DNS security, advanced URL filtering, uh, Cortex, EXDR integration, a couple of other component, wildfire protection. So those are the protection which we use from technology perspective, and there are multiple different model. I'm going to discuss that in the zero trust model, how we can use similar model to enhance the performance across the data center and the branch offices. Cisco eyes, when it comes to zero trust, Cisco eyes will play a very key role and for ISO 27001, because this is where we are saying that any user, any device, any asset which is connecting to our network, it has to authenticate through the certificate. Generally, we used to log in with our username and password, and you used to get connected to the network. Now, once you log in, authenticate with Active Directory using your username and password, then there is additional layer. You have to present the certificate, uh, whether you have the valid certificate or not, then only you will get the access. Splunk, there are SIM solution, Splunk, Rapid7, Securonix. Those are the security incident and event management solution. Basically, it will collect all the events from all the servers, whether it's in data center and branch offices, and collect all the logs and store into the uh, petabyte storage. We collect the event every second. The licensing goes even per second EPS. So we need to be very careful on the licensing. Generally, we use only critical logs to be stored. Storage and protection, there are multiple stack. We use technology stack, uh, HP3 par, EMC, which is now Dell. So those are the high performance SAN arrays. HP3 par, I have done numerous implementation with HP3 par. They are one of the best in the market. Pure storage NetApp. Generally, these are the next generation flash arrays we use for the file share or comprehensive data management solution, especially when it comes to the hybrid cloud. Commvault and Veeam. Veeam solution we use to back up the virtual infrastructure, and Commvault when you have heterogeneous platform, Linux, Windows, virtual infrastructure, physical infrastructure, we use Commvault solution. So those are the enterprise grade level technology stack which we are talking about here. Proven business outcome, yes, when we enhance our data center, when we implement the ISO 27001 controls, and on top of that we build the data center at the foundation of ISO 27001, the value, the business which they wanted to see, the infrastructure reduction. That's what I talk about in the earlier slide. The physical footprint will reduce drastically with the hyperconverged solution and with the cloud integration. There are a couple of tools where we the backup solution where the backup will store in the cloud based storage. Those are the solutions. So that way you will completely remove the physical footprint in the on-prem infrastructure, and cloud infrastructure integration can be taken care. Workload mobility, enhanced agility, enabling rapid response to the business demand. Since we gonna reduce the footprint, and we have the centrally managed solution, for whether it is Nutanix, whether it is Cisco Hyperflex, whether it is FlashTag. The management solution is so vast, so easy. Uh, it's in terms of virtualization is simply drag and drop. So workload mobility, you just drag the VM from one host to the another host, right click and say vMotion, then you will move to the different. If you want to increase the performance, increase the RAM or compute and everything, you can do it in a second. So that's the outcome or business value you're gonna get when you're gonna enhance the modernize your data center with Azure 27,000 control. Cost saving, of course, since you're gonna reduce the physical footprint, power consumption, number of racks, electric and mechanical consumption, AC consumption. Definitely, that you will see drastic cost saving there. DR improvement, since we are going with this hyperconverged solution, virtualization solution, uh, when you have primary data center and DR, when you use a tool like VM backup and replication, the entire infrastructure will get replicated to the DR side. And in case the primary VM or primary data center goes down, you have the entire hyperconverged or infrastructure ready. Of course, there are a lot of DR drills you need to follow, the best practices, the automation needs to be taken care. From DR implement perspective, we need to make sure that what is the organization, RTO and RPO, and make sure that we align with that organization OKRs and strategies. Hybrid and multi-cloud migration architecture. Wow, this is the hot topic, and as you know, in current organization, in the current market, there are numerous merger and acquisitions are going on, which tends to lead to the hybrid and cloud migration scenarios. Uh, I've been involved into more than 5 to 6 uh, merger and acquisition. So the way we're gonna do is we do the assessment, make sure that ISO we map all the ISO 27001 controls and identify the gap. Once we identify those gaps, then we will harden the infrastructure, make sure that we have all the controls in place. Then we go with the phased approach, and move the workloads with the zero trust policy. We don't want to move the workloads there, whatever garbage or whatever we have, we don't want to move that. We just wanted to make sure that we assess, we see the gap, whatever gaps, the way we do it when we implement the ISO 27001 certification. Similar way, we see the gaps and then we make sure that we harden, we prepare, we implement, and then we'll go with the migration. Again, the phased migration divided into multiple waves. uh, Make sure that the stakeholders are informed, communicated, and we do the pre and post migration validation checklist, QA testing and validation, and then we'll move forward. Once we migrate, then we move forward and make sure that the operation is having the required compliance and the performance. It's not about just implementing the security and we are compromising the performance. We'll make sure that we migrate and make sure that we have the performance and user experience there. And we're going to monitor the infrastructure continuously. There will be a methodical approach we follow. We'll discuss in the upcoming slide. Zero trust security implementation, as I mentioned, never trust, always verify. Palo Alto is the key component which we use, which will provide the application awareness, traffic inspection at the gateway level, and at the same time, ISO 27001 required these controls. Cisco ICE identity-driven network segmentation. Uh, when, as I mentioned, any device, whether it's laptop, IP phones, audio video device, security cameras, printers, all those devices has to have the certificate-based authentication. They get segregated based on their tagging, associated VLANs and everything. That's the segmentation we are talking about. So when you connect your IP phone, we configure the IP phone with all the configuration. When you connect the IP phone, there is a profiling. The IP phone will go into the respective profiling or IP phones hierarchy, and then the IP phones policy will be implemented. So that's how we do the segmentation piece, and then we'll continuously monitor the behavior of the those assets. Disaster recovery transformation, yes, identifying the gaps, making sure that we understand the RPO and RTO target from the organization, document the dependencies, and moreover, understand the workflow of each and every application, have multiple interviews with the cross-functional team, make sure that they have the right MOPs, SOPs in place. They make sure that they have the process, how to, when it comes to the DR drill, how they do the DR in methodical format, make sure that they have the right run book in place and validate with the stakeholders. Um, and architecture redesign. See, when it comes to the DR drill and all this stuff, it looks very fancy, cool. We have DR in place, and we are doing that DR quarterly or annually, and providing all the artifacts, making sure in worst case scenario we have the backup in place. We have the right backup, whether using Commvault or Veeam or net backup, backup exec, whatever solution you use, make sure that we have the backup. And moreover, backup, make sure that we have the automated failover orchestration, which will help you in transforming the disaster recovery solution. I think we discussed about the hyperconverged benefits, simplified the management because it's going to have the single pane of glass for computer storage, networking, or we're going to reduce our operation complexity and provide the required training. Um, so that's the piece, and then automation will be in place, patching before for physical infrastructure. When you patch the server, if server crash, then we need to restore the server using bare metal technology. But now, since we have hyper-converged solution, if uh, VM is get corrupted during the patching and all those stuff, then we just restore or replicate the other VM which is available in the DR. Software defined architecture and their impact. As I mentioned, I've done the couple of data center transformation. Software defined networking, it's going to impact your. This is the key component for your data center modernization or your infrastructure modernization. I will give you the simple example. I had one of the scenario. I had the greenfield and brownfield. In the greenfield data center or office, I had new Cisco devices compliant with the software-defined architecture. We built the Cisco DNA center, Cisco Eyes, Cisco wireless infrastructure, everything, and we onboarded into Cisco DNA center. The way software-defined architecture works that when you bought a router or firewall or switches, you just drag and drop into the respective hierarchy. Or let's say I built the architecture campus A and campus B, and if I drag the switches and router under the router's hierarchy, the configuration, everything will get deployed automatically. There will be a golden image defined for routers, switches, firewalls, wireless access point, wireless LAN controller, everything, all the configuration get pushed automatically, no manual interaction there. And then other than that, the automated policy, automated monitoring, automated security enforcement will be there. This is applicable whether you have multiple, you want to isolate multiple tenant, we can do that. So this enable us rapid deployment, boost business agility, and accelerate time to market and supporting digital transformation. I think we discussed about petabyte scale migration excellence, mapping the dependency, optimizing the network, and then phased approach validation and cutover. This is something which we discussed earlier. Building automation first, yes, this is the key component when it comes to the modernization. There are a lot of components available in the market. Ansible automation platform, GitLab, CI/CD solutions, Terraform. So these are the solutions which will automate your infrastructure drastically. And again, it's not about technologies or technical component which we're going to implement. We need to make sure that we have the right skill set available within our organization, and make sure that we invest in training them, and so that will be the success factor to the automation. Yeah, because most of the organization, they implement the solution everything by involving the vendor, but they will not be able to take it forward to the next level or enhance the optimization. It's not we are not providing value to the organization that way. Transform with confidence. Yes, global data center modernization is achievable with security and compliance and operation excellence, and architected in the beginning with all the ISO 27000 controls in place. There is a methodical process which includes planning, provision architecture, multiple blueprint, commitment to the security and resilience, and the result will be measurable, sustainable, and transformative position enterprise for long-term competitive advantage. The key takeaway for this is integrated security, compliance, and the enterprise-grade technology, which we have already discussed. The outcome and sustain the method what we're gonna use. Yeah, that's the key to the success, the method. And before we wrap up, I would like to say that when it comes to the enterprise grade technology, we talk about Palo Alto, Cisco, Meraki SD-WAN, SIM solution, hyperconverged solution, backup solution, MDM solution, EMM solution. All those controls have to be in place in order to modernize and at the same time have those right control in place. Um, um, I'd like to say that true modernization is not just about moving the workloads and adopting new technology. It's about building the trust with cross-functional team, building the trust with the implementation partner, vendor. There will be multiple uh, ISP provider, telecom provider, Verizon, AT&T, um, multiple other solution available in the market. So we need to make sure that we have that trust with them and try to build the uh, research framework and try to bring the innovative approach to the modernization of the data center and enable the resilience. With the right strategy, with the right architecture, and with the right mindset, transformation will become not just achievable but also repeatable and sustainable. So that's my uh, speech for today. And once again, thank you so much for your time and participation today. It's been great session. I hope you leave with new ideas and confidence to lead your own modernization journey. Thank you so much. Thank you.
Thank you so much for the great presentation. For a first timer, you were great, and we learned a lot from your session. So big thanks for your presentation,
Thank you so
Raj.
much.
Uh, I wish that I will see you in another event of ours. So thank you again so much.
Absolutely, I would love to be part of your any event. Please do let me know. I'm more than happy to be part of this prestigious event which you are leading. Thank you so
Perfect.
much for your
Perfect, my
leadership
friend. Have a great
qualities.
afternoon. Have a great evening, morning, uh, and a great weekend.
Yeah. All right. Thank you so much. Thank you.
Yeah. Bye bye, my friend. Bye bye.
Yeah.
So yes, that concludes Alim's session for today, and we will get into a small intermission, let's say, and we will be back with the next speaker. I don't know if he will be able to present because I haven't found him yet, but we don't have any issues here. There are other speakers that will continue when time comes. Uh, See you in a bit, everyone. Thank you so much. Here we are again. We're continuing our session today. With us, we have Siva Manikanta with another exciting presentation. This is about Azure and Azure Integration Services transforming insurance architecture. This is the second session of our event that deals with insurance. And we have to admit here, and I believe our speaker will confirm this, that the insurance industry is going under a great transformation. There are so many legacy systems all around that need to be modernized, and Azure is here to help with integration. I hope, Siva, you're ready to start your session. If not, I can continue with a small introduction.
Yeah,
Yes,
I'm good to start.
you're ready?
Yeah, I'm good to start.
Great, great. So you can also drop your screen and I will share it.
Okay, sure.
Eh, Yes, if you have something to present, of course.
Definitely, I have the PPT. Would
Great.
I be sharing it, or are you going to share it?
Now, you will share it and I will drop it in the stream, and then it's yours to do it whatever you want.
Got it. Okay, sure. Let me go back to that PDF.
Yeah, don't worry. So, everyone, this is our last day of the event. We have great speakers with us, and I'm truly honored that I have these people, submitting their sessions and taking the time to create the sessions. I know it takes time to present and create something from scratch, even if it's something that you have already there. It still needs some work, and Siva is one of these people that I'm truly grateful. Okay, I think Siva is ready to take the stage. Probably more experienced speaker, I guess. So yes, my friend, the driver's seat is yours. I will be away. Anything you need, just speak to me, and I will be there.
Okay, so can you just confirm me, whether if you are able to see my screen, the presentation?
Yes, we can see your presentation, my friend.
Okay, so you are not seeing any. I mean, you are able to see in a full window, right?
Yes,
Just
yes.
to make sure. Okay. All right. All right. So let's get started. So hello everyone. Myself, Siva Manikant Venkatesh, Nalam from Rodash, and definitely it's a real pleasure to join you guys at Azure Innovators Hub today. Definitely all the tech enthusiasts who really love to experiment, build, and try to see what's really possible within the cloud ecosystem. So now I'm actually invited to step into present here on how we kind of transformed our whole insurance system, which is predominantly siloed with a lot of legacy applications, and where I want to kind of call out how we leveraged Azure modules like event bus, database, all the different components in reshaping this integration architecture, so that where we will be trying to mark this or build this as a digital ecosystem where the data will flow very freely and innovation is super faster and compliance is built by design. The reason why I'm kind of telling about the compliance is definitely whenever we look at these insurance and banking applications, compliance is one of the biggest concern for us, and where we need to always ensure the platforms or the systems that we are building, they are always going to be compliant. And also where these solutions should be future proof in terms of fraud, or in terms of the bot level activities. So yeah, these are all the few considerations that we did as part of this digital transformation architecture. Moving on to the next slide. So what is our actual challenge here, and why we leveraged Azure services as a solution framework? So definitely like where insurance is something like where may not sound like exciting industry to transform until we really see like what is happening there. So more than decades, like where insurers are like have relied on these monolithic systems that were great at like batch processing but terrible at like real time decision making. And each system handles its own piece like claims, policies, underwriting, and hardly like with very little communication between them. So think more of this like an airport, like where there is a baggage system, the check-in system, and the air traffic control don't talk to each other. Things move, but very slowly and with lots of manual intervention. So we leverage like Azure services here through Service Bus, Logic Apps, Event Grid, and like API management, where we are trying to create a cloud nervous system for insurance operations. It's not just about the technology modernization, but it also about like the business reinvention that's going to drive the efficiency, reduce the fraud, and like accelerate the time to market. And definitely yes, the core message here is like where we are here to kind of reinforce that it's not just a transformation, but it's more of a disruption on the technology space. Moving on to the next slide. Okay, so what is our core legacy challenge that we are trying to address here, right? So definitely like legacy systems were like one of the heroes of this core insurance technology, like where we had lot of age old systems in play, like mainframes, which is handling the policy data for like, and then we had like some other applications like pretty legacy databases. And these systems are like very rigid, and they are costly to maintain, and also kind of like where these sort of like technologies or skills are kind of like vanishing from the market. So lot of insurers within this insurance industry are like spending more than like 70% of their IT budget to keep the systems running. And definitely like where they could drive that spend, or they could transform that spend towards the innovation. And that's way like where customers can really get like real time updates, digital processing, and like 24 by 7 support from these companies. In this paper, where we are trying to describe this as kind of like a technology inflation point, and where how these legacy systems are kind of transforming from like being assets to being liabilities. Definitely like Azure's modern approach has helped us these insurers evolve without pressing the restart button, where they can adopt a hybrid coexistence model, and where cloud components can slowly take over their workloads while the core systems stay stable behind the scenes. So definitely that means like where there is no massive downtime, there is no data loss, just it's a steady modernization at their own place. So it's kind of like where if I was asked to just wrap this up like in a one liner, it's kind of like upgrading a plane while it is still flying as well. And coming to our core research objectives here, where we kind of like try to did lot of data analysis even before like arriving at like some of the core pillars of this initiative. First and foremost is like how effective is going to be this Azure integration services as a modernization engine. So what are those core services or real world complex problems that we want to solve? And where when we say we solve, we just not only looking at like to solve them through POCs, but what are those core systems that are providing that real value add behind the behind the screens. And then the next one is like where we focus a little bit more on those architectural patterns, right? How can these architectural patterns are going to be effective? And where we looked at like different architecture patterns like event driven design, like API gateways, microservices approach, and like even monolithics as well, because nowadays like we've been hearing in a lot of industries like where people are moving from like microservices to the monolith architecture in terms of like challenges around maintaining these systems. And definitely like I'm going to deep dive more into these patterns. And the next one is like where we want to really quantify or like capture the metrics around like throughput, compliance, and the latency standpoint. And also like where we are trying to create a, you know, a framework around it, where we should be easily able to like show this business value in terms of like how our existing system was performing versus like this modernized application. And definitely yes, the final one is like where we created a framework so that like why can't the others in the industry can also replicate the same thing, which is kind of like moreover like a modernization playbook for insurance enterprises who are very passionate and like moving into this cloud based architectures. Moving on to the next slide. So yeah, here is where we are today, right? So basically like where we start to connect research with some real world data evidence. And definitely like where we are seeing kind of like three distinct eras. One is like the mainframes era, like pretty old, and then like in the middle ages like we had like client server architecture, and right now it's like more like cloud native era, right? So if you look at like some data samples here, like almost like 78% of these insurers are like saying integrations are the real bottlenecks and are their biggest transformation barriers. And definitely like where even there are some metrics being captured from the Azure service bus standpoint, like where the clients are like the companies who adopted the Azure service bus and the API management modules, they were like able to report their throughputs 65% faster and more better reliable systems. So definitely like this data is going to prove us that where it's not about like, you know, struggling because of like the industry dependencies, but it's over like where it's struggling because of that transformation gaps. And that's exactly where we looked at like our integration architecture and considered like Azure as our core platform or cloud infra, where we are going to, you know, start with like one module at a time, and then like we leverage this complete microservices architecture to build the APIs on our new infrastructure. Let us talk about like the four different dimensions of the microservices architecture or microservices framework. So when we look at the bigger picture, where the transformation is not just about like the technical piece of it, right? It's about like four interconnected dimensions. The technical dimension, definitely like where we could see cloud native architecture, microservices patterns, and API gateways are like forming the foundation. And then like the operational dimension is all about like DevOps, observability, resiliency engineering, and basically like how do we kind of like keep our systems healthy day by day, right? And also like how do we ensure that we will be we will be notified or alerted whenever some of our critical functionality breaks down through our inbuilt SLO dashboards or SLO based metrics. And the third decision is more around the strategy, where we are completely focusing on like business agility and customer centricity, where we are trying to do everything in a one final place, and which is like the common space for deriving or like executing this whole strategy based initiative. And finally like moving on to the governance layer, where we are going to, you know, define our compliance requirements. We are going to, you know, kind of like embed this policy level or monitoring pieces right into the architecture, but not just as if like where to mold them into the architecture, but it's moreover like to consider them as a core design principle. Yes, we all know that where in insurance, like insurance world, like where compliance by design isn't nice to have. It's a difference between launching a product and getting blocked by regulators. So definitely like where we are trying to address that compliance piece as a core design principle versus like just trying to mimic that on the existing modules. Moving on to the next slide. So let's talk a bit about like our methodology, or what are the data sources that we really considered here, or kind of like how we studied this modernization, or like how we really looked into this modernization piece. So we tested like different ideas, like where through a series of like real modernization projects, and where we have used a lot of different approaches, where we did some quantitative data for metrics like latency, throughput, and scalability, and also like we did some qualitative insights from like interviews to our stakeholders or business leaders or architects who are being like you know building a lot of functionality on top of the existing systems. And also like we examined these architecture diagrams and conducted like some compliance audits, and also like analyzed the financial results. And in the end, like it give us a confidence that like where we just didn't talk about the integration, we measured its impact. So that's where like research will really sets the stage for like next action, where we will see like how Azure integration services actually come together to deliver that impact in the practice. So let's move on to our core piece now, the architecture. Yeah. So here is like where we are using a suite of like cloud native integration services with major philosophy of like low code platforms, hybrid and like scalable connectivity in our enterprise landscape. And the way that we are looking at is like where this could be the backbone of the entire transformation, where we might think it of I mean like we might think of this as like a unified toolkit which is going to help the old systems and new platforms to talk to each other in a real time without forcing a complete rebuild. And definitely like it includes all those four critical components as I just mentioned. Service bus is kind of like where reliable courier which is going to deliver messages between the systems. Even though if one of them is temporary offline, we are going to kind of like persist those messages at the service bus level. Logic apps is kind of like where which is our actual visual automation engine, where it connects everything from like Salesforce, SAP, or it could be like on-prem databases using the pre-built connectors. And API management, definitely like it's a front door of our entire application, where it's going to define the security, tracks the request, and manages every API calls within our organization. And finally, like the event grid, which is going to handle the real-time notifications, where it makes sense the systems to be responsive and event driven as well. So together like these tools are from like a governed policy based integration layer which are really built for scalability, compliance, and the control. And where we had a wish that we want to automate everything starting from code to climb, and this is how exactly we plan to implement it, or we really did it. So let's talk about those integration patterns in the insurance layer here. So the first one is like in the insurance world, like where we can kind of like segregated them as a key workflows. For example, like in the claim processing, Azure enables us like those event driven workflows that trigger fraud detection, auto adjudication as soon as a claim hits the system, right? And similarly, like within underwriting world, where it orchestrates data from multiple data services in real time, like pulling their credit scores, risk models, policy rules, where everything was stitched together through a logic apps configuration and API calls. And for document intelligence, where we are using the AI models on Azure, which are going to extract the information on from the scanned PDFs or these submitted forms, and even like at times like we are even sharing or sending our medical reports also to these AI models, and that is kind of going to use that capability of like the content reading capabilities, like where it will scan through those documents and give us the real insights to the reps or the teams who are really working on these top of these claims information. And definitely like then we have analytics, like where the real time streams from the service bus will be feeded directly into like snipes or like Power BI dashboards, which are going to provide live insights for the business decisioning. We are also seeing a big shift towards like, kind of integration as a service, as it's going to standardize our development effort, cuts down the build time, and makes the complex integrations also repeatable. And this is how like where we are trying to accelerate modernizationing without reinventing every wheel of our applications. So let's see, I mean, like with a real case study, what it looks like on this building these systems on top of the Azure cloud architecture. So one of our first use case is like where regional property and like casualty insurer, which is kind of like a mid-sized established system, which is kind of where more of like a mainframe and a .NET applications. So there is a challenge, right? So where we need to integrate this code generation, policy issuance, and claims, which are kind of like each piece was in a different silo. So this is place where we started adopting our API first strategy, and where we gradually wrapped up new Azure based services around these legacy systems, replacing them piece by piece. Then we used a service bus for event routing and logic apps for orchestration and Azure functions for computation and like Cosmo DB for the data purposes as well. And in no time, like where we could see the results were remarkable, where code generation become like 73% faster, and even the maintenance costs were dropped by 60%. So then we launched these three new products within like some 12 to 13 months time frame, and then that set the real tone for this entire modular modernization of like the technology disruption. Moving on to the second use case, where we had like national life insurance provider. So this is going to more about like how Azure is going to scale for like larger enterprises, where national life insurance provider like needed to unify multiple systems for life, annuity, or term based insurance products, each managed by different departments. Then we built a unified data layer on Azure using the event grid for real time processing and data synchronization for like nightly data orchestration and Power Platform for front end agent and customer portals. So everything was kind of like consolidated in a Synapse analytics, so that like leadership could finally see like cross product insights in the real time. And the impact is like 80% faster customer onboarding, 50% less customer support time, and an annual savings of over $2.3 million. And we also kind of like discovered something unexpected: data visibility, where it doesn't just improve the operations, but it transforms the customer trust as well. And finally, like we could see like now agents could explain the policies and updates the policies instantaneously. Sometimes even customers feel that like it's very rapid. So moving on to the performance and the operational metric side of the things, where our systems has like processed the latency, has dropped the processing latency by around like 3 to 5 seconds from 45 minutes, and the throughput capacity has hit like 50,000 messages per hour. And then like the reliability also reached like 99.95%, and definitely like where we are also having the mean time to recovery dropped below 10 minutes as well. So even sustainability got a boost, where these cloud native models cut the data center energy used by like 30%, aligning with like our ESG goals. When we combine this technical performance with the business impact, we see the real ROI of like integration architecture, speed, stability, scalability, and all working together. Of course, all this modernization only matters if it is like secure and compliant. And in insurance, that's definitely like non-negotiable. Azure makes like, sorry, I updated the next slide. Okay. So definitely like Azure makes the compliance by design a reality where every message is kind of like can be traced end to end using Azure monitoring and visibility for audits. Also, like we had placed a lot of data residency controls ensuring like alignment with HIPAA, GDPR and NIC, so irrespective of the region, which has really enabled us to build a zero trust access layer through Azure private endpoints and encryption at the rest and even within that transit layers, so which is kind of like created a lockdown environment. Even we are able to like do the key management through Vault, which is kind of like our centralized repository for managing the credentials, policies and the blueprints. And definitely this is where one of our compliance officer asked like, who accessed that claim record, can you answer in seconds? Yes, definitely, like we had that level of transaction monitoring or traceability across our life cycle of the system, and where it's really evident to pull such clear cut details under a few seconds versus like happening in hours or like days in earlier scenarios. And that's what definitely like where we understood that integration architecture is not just about like plumbing, but how can we make it as part of our trusted architecture. So moving on to the next slide, where I want to cover a bit about like, you know, future trends. So before we really talk about like future trends, I want to just close on, you know, some of the key takeaways from these case studies. First of all, like where we need to start incrementally, not at all at once, and then we kind of like leverage the strangler fig approach, which is kind of going to minimize this disruption. Second, we think that API first and event driven approach, that's the only way to stay agile and scalable. Third, where we are trying to bake in that governance pretty early and make sure that like your compliance is fully automated and we are free to innovate. And finally, across all our projects, the pattern is consistent, right? Where insurers who treat integration as a strategic capability outperform those who see it as a technical task. So this is how we build the systems that grow, not just the systems that work. Let's move on to our final piece on like discussing about like the future trends and what the future looks like. So where does these insurance can go next? Right, the next wave of transformation will completely driven by like AI, blockchain and LLM based or agentic applications, where if you start with an AI integration, let us see like where we can imagine a use case like where the claims which can be validated themselves, right? Where we can leverage like Azure Cognitive Services and Synapse ML models, which are going to enable the cognitive claims processing, predictive underwriting, and even chatbots that guide the customers through the claim submissions in the natural language processing. AI is no longer a nice to have feature. Definitely, it's fast becoming the front line of the customer interaction. And similarly, like in terms of like leveraging the blockchain capabilities, where a lot of insurers are experimenting the smart contracts that automatically trigger the payouts whenever there is a predefined conditions that are met. This means reinsurance settlements that used to take weeks can complete in the hours right now. And finally, like IoT, which is another frontier, where think of these as like a connected vehicles of a property sensors that continuously going to access the risk, and where Azure IoT Hub connects this data back into the underwriting models in the real time. And finally, like in terms of like sustainability, like this is a theme that's very close to every company's mission today. Azure's carbon aware workload routing and like optimization tools are like helping insurance companies to reduce their data center emissions like by as much as like 30% without even compromising on the performance. Together, like these innovations like mark the shift from the digital insurance to the intelligent insurance, where systems don't just react, but they simply anticipate. Okay, so before moving on to the conclusion, so I want to kind of like spend couple more minutes on the composable enterprise architecture, where definitely like the future architecture of insurance is what it looks like, a composable enterprise. Instead of building that rigid applications, insurers will use those modular building blocks or microservices, which could be rearranged or scaled or reused to new products on demand. And this is the need of the hour, where we need to launch a new travel insurance product next week instead of like next year, where we want to take the advantage of this configurable and deployable components, which are covering all the aspects of like pricing, risk, document management, etc., which are exposed thoroughly through a secured and scalable APIs. This is where integration architecture becomes more like business architecture, and it's not just about like systems talking to each other, it's about like enabling the entire new business models. And that's definitely a big shift that we are looking at, from one size that fits all policies to personalized real-time insurance experiences as well. And yeah, definitely like the framework that we choose in order to evolve this whole enterprise architecture is like where we consider that like we call it as a connectivity centered transformation framework, where it starts by decoupling the customer experience from the backend systems so that digital channels can evolve independently. And then it comes with a unified information architecture and consistent data patterns, which are going to be consistent and which are going to provide like consistent data, consistent access, and consistent governance. Then we established a dedicated API management as a product discipline, treating every interface as a measurable and reusable asset. And finally, the protection layer that evolves into a zero trust and compliance by design, where every transaction is both secured and verifiable as well. And finally, we integrate like analytics and event processing directly into the business workflows, and we are trying to make every system becoming a capability as well. And I want to touch a little bit about like on our guidelines or recommendations for implementing such sort of systems or like enterprise applications in a typical digital transformation world, like where we can always like start with like an integration landscape assessment and really map out like what are the systems that we had and like where exactly the data is living and how it has to flows together. Then we can kind of modernize incrementally using that strangler fit pattern, and where we can replace the components bit by bit, not at all once. And finally, build event driven or API first architecture from day one, which is going to enable the real time scalability. And then invest in the observability and the DevOps early, so that like automation is your safety net. And finally, like implement compliance by design, so that like governance is something that travels with your workloads or whatever or wherever you execute them. I mean, like even I can say like in terms of the examples or like use cases, like where these sort of framework or scenarios can be leveraged even beyond the insurance industries as well. It could be like banking, healthcare providers, or logistic firms, where every every domain is kind of like facing the same challenges, and these legacy systems that can't move at the speed of customer expectation. The Azure ecosystem with its mix of low code, AI, and scalable integration is what bridges the gap. It lets enterprise innovate from within using what they already have as the foundation that comes next. And that's the future of like digital transformation, continuous, connected, and compliance system. Okay. So as we wrap up for today, I kind of like want to call out like few specific data points in terms of like our final conclusions and like some recommendations around it, where we need to understand that integration architecture is not just about the connecting the systems, it's about like connecting the possibilities. And Azure Integration Services provides the foundation for resilient, secure, and scalable ecosystems, which are going to power the next generation of like digital insurance and beyond. And from legacy systems where we are trying to build intelligent ecosystems from disruption to the transformation, and that's the journey we are on. And whether you are an architect, developer, or a product leader, your role is always like to keep those systems or connections alive, to turn technology into a trust.
That was a very interesting presentation. Thank you so much, Shiva. I really enjoyed it a lot, and I'm definitely going to see that again. Uh, for everyone that won't be able to watch live, this 4 days event is recorded and it is streamed on YouTube. So yes, you can connect to our channel, Azure Innovators vlog, and you will be able to see all the sessions, including Siva session, which I found it again very interesting. So thank you so much, Siva, for coming in and delivering your very interesting session, to tell you the truth. Uh, I don't have any questions for now. Our audience mostly watches our streams later, but we have international audience, so I will send you the link. I will send you your badge, probably from Monday, where we are concluding, and I will also make some adjustments to our recordings. Thank you so much, my friend. I hope to see you again in another event of ours.
Thank
Until
you.
then, have a great one
You
and
too.
have a great weekend. Bye bye.
Bye.
Yeah, that's it. And we are moving on to our last day with the third presentation coming up. It is Mahish, and it's about Azure Data Trust at Scale, Engineering Managers Compliance Innovation Guide. Another interesting presentation. And what I have observed so far from our speakers and from the sessions they are delivering, I don't know if you're noticing it, but we are starting to move deeper into the capabilities, into the possibilities, and into the requirements of our era and the cloud um, adoption, the cloud journey, the cloud platforms in general, and of course Azure. So we saw ISO 27001 with Alim. Now Siva Azure Integration Services for the insurance architecture and data trust at scale for compliance and innovation. And the last presentation would be scalable, agile, and cost-optimized e-commerce with microservices and serverless. So a lot of themes, a lot of interesting themes to explore and learn. What I really like about our speakers this for 2025 is the expertise. I'm noticing a shift in the expertise, and I know that people have put a lot of effort, a lot of reading, a lot of night time of learning and trying to keep up. But when you put yourself there, you put your heart and your will, you are able to create your own diamonds. And this is what we're getting now from our speakers. And I'm really grateful for our 4 day event that we were able to pull. Now, I'm sorry if anything have gotten a little bit erroneous or here and there are some mistakes that may have been done basically by me, but I'm the only host here, So forgive me. At least you've seen that I'm able to edit the videos, and after 24 hours when the stream ends, and this is a policy by YouTube, I'm able to cut down if there are long pauses, and you are able to enjoy them. And I know that you will enjoy them because I have seen we have a number of views that sometimes hits thousands of views. So please subscribe, please invite your friends to join our channel and support it. This is the only way of support we have. We don't have Patreon, we don't take money, and I will try to keep that way. Another announcement, we are going to shift up our game. I'm going to get um, some equipment, some better video cameras, probably a tripod, microphone, which is very important. I'm hearing my streams, our streams, after the events, and the microphones of the headsets, they're not good. We need something more professional and able to not pick up noises from around. So I have already chosen what I'm going to get. So our streams will be much, much better for everyone to enjoy. Let's have a small intermission while we wait our next speaker. It's Mahis. I haven't seen him and he haven't responded, so I don't know if he will be here. It's a little bit early to tell you the truth. So let's get a 20-minute break. It's not bad to get a break for everyone. So see you in a bit. Right. So I don't see my keys coming up. This is a little bit of an issue, but we are used to it. Yeah, we are used to it. It's not the first time, but I understand that people may have urgencies, things happen, and I totally respect the fact that we have families, we have other things to do, and our plans are not always going to happen as we plan them because, just like I said, issues may come. Okay, I'm going to give another 5 minutes because I have emailed Mahesh to come up. The session is about Azure Data Trust at Scale Engineering Managers Compliance Innovation Guide. Looks very interesting. I hope Mahesh will come up. So it's just 5 minutes more and then we will handle it another way. Yeah, we cannot find Mahish. I haven't got an email yet, so give me a moment to prepare something just to fill here the time. And I will contact also our next speaker just in case. Maybe Naveen will be able to join earlier. So why not? Let's try that. Okay, give me a moment, please. Thank you very much. I'm preparing something for you, so excuse me. Let me change the. Okay, so what we are going to do now is I will take over and I will be your presenter. Let me fix my camera so we'll have a good visibility. I'm sorry for that. I was not prepared to deliver a session, but things happen. So we must be ready. Okay, give me a moment. And I also realized that I can use my mobile as a camera, and that is very, very interesting. No, I don't like it. Okay, I will be diagonally looking at you, and I hope that's not a problem. Great. Right. You can see me, I can see you, and I will switch off the camera for the presentation. So what we're going to cover up until Navim will be able to join. We're going to see, let me move this to another window. We're going to explore Microsoft Fabric. Microsoft Fabric has gone under a lot of transformation, a lot of updates and upgrades, and it looks amazing. Um, the point with Microsoft Fabric is that you are able to use it as a trial with an actual capacity license. So you're not obligated from day one to start, putting your bills on. Especially if you are a developer and you own an E5 license, you can, start a trial with a user, and you can get an extension on the trial. So you may reach a total of 90 days using Microsoft Fabric in our case. So let's have a quick look. I'm going to stop my camera and I'm going to share my screen. I'm going to use this tab. Great. So what you're seeing here is a Microsoft Fabric main window. Okay, how we connect to Microsoft Fabric? You need to put on your URL app.fabric.microsoft.com and then log in with your credentials. This is the first screen that you're going to see. A lot of options here, but we're going to take it slow. This is an introduction to Fabric, let's say, session, and I'm going to be as much as simple as possible. Uh, the first thing we need to understand here is how Fabric works, how Fabric separates user artifacts, elements from other users. The main component here is called a workspace. So once I connect to MS Fabric as user X, I'm going to be assigned my workspace. This is my default workspace. I can create, of course, other workspaces. So for example, I can go from the main screen to do that, or from the workspaces menu, where here I can see which workspaces I have access to. Other users can share their workspaces with me, so I can have access to them. Of course, I can also share my workspace with other users and provide access to my workspace for other users. I can create a new workspace. Let's create a new one, and we're going to name it Fab Innovation. A workspace for data streaming. Now, we have the capability to work with domains in Microsoft Fabric. Let's have a quick look at what a domain is. A domain is a way to separate workloads within your Fabric tenant. So you can have a domain that has a certain number of policies and controls, and another domain or a subdomain that does something totally different. Okay, but it's not the main case here of the domains. Okay, we just create a workspace, we give it a description. Let's upload a nice icon here for us. I love icons, so forgive me, I'm going to add a nice icon here. Let's provide something that looks good. Oh, I have here some icons. Okay, yeah, probably this one. It's good. Okay, in the advanced now drop-down menu, it's what it gets interesting. Your license mode. When you first start a Fabric tenant, from your first connection to it, you are getting assigned a trial license. You can go to select a pro license where in that case you're using basic Power BI features. You're not into the Fabric um, playground, okay? Because Fabric and Power BI are living under the same slice, let's say. But anyway, you have this capability to create a pro license, especially if you're a business analyst. This is the way to go. You're going to select a pro license for you. You can go to premium per user. This is an enterprise level summary license, especially for companies and corporations. And in our case, where we are in a trial, we have the capability to work with a Fabric capacity. Okay, it's been given to us as a trial, as part of our trial. So you can see here that we're getting a semantic model and the capacity. You can see that you can select, you can see from the drop down your capacity and where it lives, and whether you're going to need a large or a small semantic model storage format. This is about your analytics artifacts. For example, are you going to make visualizations from a large subset of data sets, or your data sets are just a number of tables with um, limited rows? You don't need a large semantic model in that case. Your storage, your data doesn't fit the narrative of a large semantic model. A small, in most cases, is just perfect. And then you can also ask to develop template apps. Template apps are developed for sharing outside of the organization, and it is created for developing and releasing an application through a templated way in our workspace. I want to keep it clean, so I won't prefer something like a templated app. So let's create our workspace. I don't want to go to the uh, paid license, so I will click free, and then you got 60 days. All paid Power BI features are yours for 60 days. Got it. So this is a Power BI trial, as you saw. Let's see what we have done here. I'm a little bit worried that we just got Power BI. No, you can see here we have this diamond. That means that our workspace has all the required configuration elements to perform in the Fabric and the Power BI um, areas. Okay, so we can create a number of things here. Here is where Fabric gets interesting. Let's see how we're going to manage this. First of all, workspace settings. Let's have a look in our workspace settings. What does this mean? Workspace, as we explained a little bit earlier, is where we are managing our um, place, our collection, let's say better, of artifacts. Okay, and by artifacts we mean we can create pipelines, we can upload some data in CSV format, we can create applications, and workspace is our grouping of our elements. It's a way of doing our work in Fabric, and we are getting into a workspace. We're getting assigned a workspace. You can see your license information, and you can also see and configure any connectivity to Azure. And by any, I mean Azure Data Lake Generation 2 storage and Azure Log Analytics. You can see your system storage. You can also integrate Git. What does this mean? It means that you can create a connection with Azure DevOps where you can synchronize, we can have a version control system for your elements that live into this workspace. Okay, specifically elements are supported like pipelines, etc. I don't remember exactly which elements, but the most important ones are there. So in case you want to make a reverse or change something or keep a versioning of your pipeline, set your code and your notebooks. Yes, here is a nice tool integrated into Fabric so you can work within DevOps. Also, your developers. Suppose you have Python developers creating your Spark notebooks. Notebooks are an artifact in Fabric that you can write code and this code is executed sequentially in the notebook and they perform certain tasks. For example, connect to a storage account, get the CSV file, clean up any empty row, and store it back into my Fabric storage or store it as a new table in my SQL database. You can do a lot of things. Python Spark is very powerful. And another thing that I need to mention here that is important, this is what you are paying for when we are talking about capacity in Fabric. You're getting a Spark cluster that provides computing power for you to execute your notebooks. Okay, one lake. One lake is what Fabric um, defines as its main storage. Okay, and it is not only about the storage abstraction layer. Okay, it is the storage as it is named in Fabric. It is one lake. It is a data lake at the end of the day. Okay, we're sitting on top of a data lake where we can create delta tables. We can utilize all the goodies of a data lake. The workspace identity is something very important because you can assign a workspace identity and use it so users can authenticate to other data sources as a workspace identity. So we can authenticate our workspace to an Azure function, for example, and we want to execute some automation. We don't need to find a way to authenticate like a user. It's like managed identities. Outbound networking. Fabric offers the capability to create private networking. So you can utilize private link, subsequently private endpoints, and you can have your own virtual network integration for your Fabric workspace. That's very, very important, especially for regulated organizations or in cases where you need strong security and isolation. The same stands for inbound networking, where you can control which and what connects to your workspace. Encryption is by default in Azure, but we have also the capability to use our CMKs, meaning customer managed keys. It is currently available in a limited number of regions. And monitoring. Monitoring is where you monitor your workspace. It is offered by default, let's say, or it's integrated already into your workspaces. So you just need to create your monitoring event house. Remember, it will consume capacity from your workspace. So unless you definitely need this, you don't need to create it. But from my experience, 90% of the organizations that are utilizing a workspace for production reasons, they need also a monitoring event house to to monitor what's going on, right? How our pipelines are working, what's going on with our consumption, and all that nice things. So that was about the workspace. And that's not only that. There is also something that I didn't show you. There are more controls. These are the controls for the generic configurations, and then we move on. Power BI configurations allow contributors to update the app, okay, and template apps as we saw earlier. Data connectors, you can enable granular access controls for all data connections. And embed codes, we don't have any embed codes in our Power BI. We don't have even yet Power BI enabled, I mean visuals. We don't have any semantic models prepared. Delegated settings, we have the one leg settings where we can authenticate with one leg user delegated SAS tokens. You can see here SAS, signed access signatures, right? And this is something that goes hand by hand, especially with storage. So our one leg can authenticate with SAS tokens if we want to, and authentications will use this SAS token, applications will use this SAS token so they can create so they can authenticate. Remember, these tokens have also expiration dates, so you can set them directly on the token itself. Whether Copilot and Azure OpenAI service will be enabled, only show AI private items in the standard Copilot Power BI experience off or on. This is in preview. Data engineering, the Spark settings that we explained earlier. Here we will see how our cluster is assigned to us. What we got? We got a medium node size for our nodes, and the number of nodes can scale from 1 to 10. I can edit it here, but since I'm on a trial, this is what I get. Okay, it's provided for me by default. I can work here with auto scaling. I won't recommend it. Leave it default, especially if you're on the trial. Okay, when you create your own pool later and you know that you are going to pay for that through your capacity, you can do whatever you want. We have a starter pool here, so this is the starter pool. Okay, you can create a new pool and so on. Data factory, Apache Airflow runtime settings. For Apache Airflow users and fans, this is a default pool for the workspace and nothing else to create. Of course, the integration is seamless. And for data warehouse, collations are case sensitive or case insensitive. Okay. One of the important aspects here for me is, let me find it. Let me find it. Where is it? Let me remember also. I need to remember. I think it's in the Spark settings. Yes, environment. Observe this menu. This is where you can create environments. So you can set a default environment and you can say, okay, this is my default environment. And what is the environment? Okay, let's see. I can create a new item and go and find environment. Let's name it Python one create. Now, this is where we can use our own libraries. We can build, right, our own character, our own uh, collection of libraries for our execution through Spark. We can select specific versions, specific libraries, and use them in our code. So we can use the building libraries, public libraries, or a custom library. We can also edit for our environment our Spark compute. Do we need native execution engine? And this is an acceleration of the Spark job using state-of-the-art methods. Available at no additional cost. For the compute, here is where you can edit the driver core, the driver memory, the executor core, and the executor memory. Okay? And some properties where you can set for your Spark cluster. A number of properties are here. So in case you need specific properties into your cluster for your notebooks, it's here where you can set it. Also, the environment you can upload files that will be available in notebooks directly from the environment. A very, very important aspect of Fabric. Why? I will explain why. When you try to create a notebook, or let me say it in another way, when you create a Python file, what do the first lines of your Python program do? They call a specific number of libraries. Okay, now there's a catch here. In our Spark notebooks, especially when we want to automate them, because this is what Fabric does, we're not going to use click operations to um, use Fabric. We need automation, right? This is why Fabric exists. It's a fully automated data governance, data analytics, data warehouse, and everything about data platform. So when the time comes and you need some automatic execution of notebooks, you cannot have installation on the notebook of libraries. You're going to need to have them already in your environment. So when we need, for example, OpenAI version lower than 1 because there are breaking changes, remember, we can define that by saying, okay, let me add my PyPy PyP OpenAI version. You can see here that it's already found it, but I don't want 271. I want something else. I want to use it in my old code, which is pre 1 version. Oh, the 028 one that works fine with my code. I don't want to migrate my code. I want to use that version. So when you try to import from OpenAI, remember in Python you import OpenAI from OpenAI or chat completions from OpenAI, it will use this version and will not break your code. Very important. How you use this? And since we are already here, it's better to see directly on how this is used. So I'm going to leave the environment and don't want to save this version. I'm sorry. Let me return to the workspaces and create a new notebook. Yeah, the name is fine. You can also manage your files, your notebooks, everything you create in Fabric in folders, right? So you can have it tidy and well aligned. Skip tour, and here you are. Here it is. And here is where you can say to the notebook, use the environment that I have created for you. Otherwise, it's going to use the default environment. So Maybe some libraries are missing, some libraries are the latest version and doesn't fit your code. You may need to be able to know this information. Create your own environments to fit your own libraries. Maybe some regulated industries use specific libraries. I have seen that, and it is a reality. So, this is a way to solve this problem. Now, this is a notebook. Of course, a notebook has a lot of configuration elements apart from the environment. This is data wrangler where you can easily explore and transform your data. You can create you can create a new AutoML run. This means that you can utilize auto machine learning pipeline. You can add it to a new pipeline and you can open it in VS Code. You can save it or uh, set it to autosave mode. So every change you are doing it is autosaved. Be careful with this. You may not need it. You may need to change this because you are working and you need to be able to follow up your changes. So you can just select not to have autosave on. This is the edit for your autosave and other elements. And here is where you add your code. You can use Markdown to mark your code, create nice um, text so you can be informed and anyone that uses your notebook can be informed and so on. AI tools is something that recently popped up in the notebooks configuration. So you can set up an AI function and a new AutoML run. It will be nice to explore it in another session. And here you can run it. Okay, perfect. Now I'm going to close this. I've heard a very interesting sound and I'm sure that our speaker is here. We have Navim with us, so let's have a very short intermission, just 1 minute, and we are back with Navim and his presentation. Thank you, everyone. Great. So it's time to invite for everyone Navim. Give him a moment, please, and I will add him to our stage. Give him a moment. Navim is going to present scalable, agile, and cost-optimized e-commerce with microservices and serverless. One of the cutting-edge technologies of our era, microservices, and of course we have also serverless, something that is also adopted by Microsoft in their OpenAI models, and not only OpenAI. But it's not about AI, it's about microservices and something that is taking over the world, if not already have been taken over. I'm watching around a lot of legacy and monolithic applications and architectures getting thrown away for the sake of microservices, the age of microservices. But enough about this. It's time for Navim to be invited on the stage. Hello, my friend. How are you?
Oh, hi, I'm good. How are you?
I'm good, thank you. Thank you. Thank you for joining. I think it's the first time we
Thank you.
meet,
Yes.
and yes, I'm very grateful that you all were able to connect and deliver your session. So tell me, how do you came up with this session? Is this session something that you have presented in the past somewhere else?
No, I have not presented. If there is an opportunity, I would present. This is my first opportunity, I guess. Yeah.
That's great. That's great. Do
Yeah.
you want to share your screen so I can add it on the stream?
Yes. Let me share my screen. Yes.
Great.
Let me figure out. Okay. Is my screen visible now?
Yes, yes, give me a moment and I will add it on here. Perfect. We can see the screen
Okay.
and yeah, the driver's seat is yours, my friend.
Okay.
You're free to start your presentation.
Okay. Awesome. Thank
Naveen
you.
Kumar, everyone.
Hello. Hi. My name is Naveen. And today I'm going to present topic on microservices and serverless, especially in an e-commerce setting. And I have more than 15 years of experience in the e-commerce industry, developing web services. So I'm going to talk about some of the learnings and how do we think about developing scalable, agile, and cost-optimized solutions. So let's get started. So this is the agenda. We are going to look at the e-commerce explosion in the recent years and the monolith problem, what a monolith is and why is it a problem. And we are going to talk about microservice architecture and then serverless computing and how these two work together and a few other architectural patterns. And I'll little bit touch upon Azure technologies. I'll not go deep into that. And we'll talk about how to optimize for cost and few takeaways from this session. Okay. So, okay. So the e-commerce explosion. So e-commerce has shown a lot of growth in the recent past, especially during the COVID times. I think everybody was shopping online instead of going to stores, and that created a lot of growth for e-commerce. It has slowed down a little bit, but it still continues to grow worldwide, especially in developing countries. Um, and this has created a lot of challenges in scaling systems for all of the e-commerce companies out there. The some of the large e-commerce solutions that we see can handle millions of customers and hundreds of thousands of requests per second, even millions of requests per second. Those are some of the really hard challenges to overcome. And we'll see how microservices and serverless helps in that. And we'll move on to the next topic. So a monolith. This is not a new term. Everybody knows what a monolith is. But I want to talk about what are some of the challenges that people get into with monoliths, right? So one is over provisioning. If you have multiple components in a single system, and if one component needs to scale, you will end up creating new instances of all these three components. And even though you just want to scale only one, you do not have the flexibility to scale only one. You have to scale all of them together, and that creates a lot of waste. And the related issue with that is the poor resource efficiency. You will not be using your CPU cycles to the fullest extent, or maybe memory, whatever is the whatever is the dimension along your service scales. And another problem is deployment delays. In a large enterprise setting, there'll be multiple teams. If you have multiple teams contributing code to the same deployable unit that gets deployed, there are a lot of challenges. If one team breaks their code, you cannot deploy the software anymore. You have to fix it. Every other team needs to wait for the issue to be fixed and then to be deployed. And then there are interdependencies between teams, one inadvertently breaking other teams' software because there are dependencies, and then you change something that is not backward compatible, and then that breaks another team unexpectedly. There are a lot of issues that happens, and this creates deployment delays. In a fast-moving environment, you want to be able to deploy as fast as you can, but monoliths prevent that. That is another big problem. These days, there are, if you want to move fast, you don't want to have a fixed deployment schedule. You want to have a fluid deployment. Every commit needs to go to all the way to production without any manual intervention. That is the only way you can move fast. And a monolith creates a lot of challenges for that. It gets stuck in so many stages in a CI/CD pipeline. It's really hard to deploy very fast, very frequently. The other challenge is a single technology. Because you have multiple components all deployed together, you are stuck to same technology or language that is everybody else is using. Even though your problem domain may need a different technology, you will not be able to use it. You are stuck with whatever everybody else is using. And that creates challenges in terms of for you to explore new ideas, improve performance, or any of those things. We will move on to our next topic, microservices. This is not a new concept. I'm sure everybody knows by this point what microservices are, how it helps. But just to give a quick introduction, it is the idea of breaking a monolith into smaller pieces, smaller independently deployable units. So in an e-commerce setting, for example, you could have one microservice for inventory tracking, one for authentication, and one for ordering. And this helps different pieces to be owned by different teams, and each of them can go fast. They have full autonomy in what technology they choose, how they migrate, how they operate it, and they're all connected by interfaces. They're not tightly connected like in a monolith. They are loosely connected, but with interfaces that defines the contract between the services. So, as I mentioned, in an e-commerce setting, you can have different microservices. These are some of the things. If you're starting a new e-commerce website, for example, right? You could start with some of these services as microservices. One for catalog, one for payment, one for inventory, one for cart and checkout. But in an enterprise setting, the scale is very different. So this is each node in this graph is a microservice. In Amazon, this was back in 2008. This was more than 15 years ago. You can see there are thousands of nodes. There are literally thousands of services, microservices existed 15 years ago in Amazon. This was tweeted by Amazon's CTO several years ago. You can imagine how it would look now. I don't know what it looks like now, but huge explosion of services. What this also shows is that there is a lot of growth, a lot of innovation. Every team is able to spin up their own service to solve the problem that they have, and they're all able to work together to power the e-commerce systems. Another fact is that e-commerce is one of the most complex businesses to run, especially if you want to go beyond country boundaries. If you want to attract global shoppers, then it gets very complex. The business use cases gets very complex, and thus the systems that support those business use cases gets really complex. And this kind of growth is only possible with breaking down your systems. Another thing that I want to call out is we always talk about breaking down a monolith, because in most cases, that's the right approach. You start with building a single service that does more than one thing. And then once it grows, you understand what are the boundaries of components that you want to create, and what components need separate ownership, what components need independent deployment from others. That learning you will get once you operate a monolith. After a point where you starting to see issues, that's when you want to break down a monolith into multiple microservices. In many cases, if you just start with microservices, what happens is that you don't yet have a full understanding of the business, what domain of the business grows. Business wants to grow independently of other. What are the proper domain boundaries between the services? It's hard to understand when you're starting. So if you start with microservices, it's possible you end up in a wrong abstraction between services. Then you start with a monolith and then break it down once you have a good understanding of the domain. And we'll move to the next one. And what I think I talked about some of this already. What you get by breaking down the services is deployment frequency. So now each services can be owned by a separate team, and they have full autonomy about how they want to deploy, how they want to build, what technology to use. And this creates faster deployment, enables faster deployment cycles. There are not multiple teams competing, in pushing their code and getting it deployed. There is less possibility of one team breaking another team. So deployment frequency increases, and overall, your ability to release features faster improves. And availability. Because the services are now separated, you get better availability. In a monolith setting, one team can break another team's code, and this doesn't happen. There's a less chance of happening this happening in a microservices setting. Cost reduction. I think we talked about over provisioning in monoliths, and with microservices, you get the cost benefit. You'll be able to use the resources much more efficiently than you would do. So independent scaling is one of the benefits we get. For example, if there is a Black Friday event going on, then you may want to scale one part of the business functionality while keeping the rest not scaled. and this enables us to do it. And there are and this also helps. I think we talked about the resource utilization. In a large enterprise setting, this can mean millions of dollars in savings. Also there is, because you can move fast, you can be more competitive. And now we'll talk about serverless. This is not the new concept as well, so I'll not go into a lot about it. At a very high level, serverless functions is basically, think of it like a function that you write, a method that you write, and that you can deploy. That's all you will deploy. How it runs, in what environment it runs, is all abstracted from you. That's what serverless functions is. What you get is auto scaling. You can set it up to auto scale automatically based on the demand. And you also pay per use in many of the cloud providers. So how this helps is, there are certain shopping events where there is a lot of requests, and there are sometimes where there is not lot of shopping activity happens. So this helps you, you pay for the resources only used at that time. You don't pay a constant, for a predefined resource. So only the during a peak event, if you are using thousands of instances, you pay for that. Maybe let's say for 1 hour. Then you just pay for that 1 hour for those thousands of instances. The moment traffic goes down, then you'll pay, I don't know, hundreds of instances if that's all you need. So these spiky patterns is where this helps a lot to save cost. If there are not many spikes, you may not save as much. And it's very common in e-commerce where you get a lot of spikes depending on the use cases. Ordering, there is a sale going on, you get spikes. And in case of inventory management, if you have large shipments of items coming to your warehouse, then that will create a spike in accounting for all of those, and then it dies down, the requests. So these kind of events are very common in many different parts of the e-commerce business, and it really helps. The other fact is that it may seem like the overall cost may seem like slightly higher with serverless functions in general compared to you deploy your own service. But if you look at the total cost of ownership, you will end up paying less in many cases, because your total cost includes the cost for maintaining those services, the cost for the people who maintain those, the time you spend, the opportunity cost. If you consider all of that, it may be worth paying a little bit extra for a serverless solution as opposed to a non-serverless solution. I think we have already talked about these points, cost savings, auto scaling, fine building granularity. You can build only for the actual compute used. So we'll move on. So there is also this other option in many of the cloud providers, serverless containers. So we know containers, Docker containers, you build and deploy. But serverless containers, what it gives you is you just build and deploy, but the scaling is automatically taken care of. Scaling, how it is distributed regionally, any failover that needs to happen, all of that is taken care of in these solutions. And some of these solutions provided by Azure, for example, can scale from 0 instances to thousands of instances in a matter of minutes. Again, here you pay per instance, not by, unlike the serverless function, here you pay by instance. If you have 1,000 instances running, you pay for 1,000 instances. In a serverless function, you pay for the time it runs rather than the number of instances. Here you pay for the number of instances. This serverless functions are mostly stateless, as in new instances can be created and removed anytime by the platform. In a serverless container, you have a little bit more control. You can have a stateful instances. You can decide how many instances you want to keep running, and you can maintain state in there. It's a little bit more flexible in terms of what you can do. And these can also run longer. There is no time bound for this. Serverless functions, for example, Azure, I think 10 minutes is the total timeout. So whatever you run needs to complete in 10 minutes. But here you have the flexibility to, let's say, a large data processing you can do that can run for hours, which the serverless function is not a good choice. This is an interesting trade-off that you need to know. With on the left side, we have container instances. These are the traditional Docker containers that you deploy manually using, say, Kubernetes or any other technologies. And on the right side, we have serverless functions, which you just deploy a function. These are two extreme ends of control. With container instances, you get better control. You can specifically decide how to deploy, where to deploy, how many instances, how to scale up, how to scale down, what kind of technology you want to use, how it is connected to other services, how long it runs. You have pretty much all the control you need. But with serverless functions, you lose the control, but you get better abstraction, because all you have to worry about there is just your code. You don't have to worry about anything else. Serverless containers come in between these two. It lies somewhere between these two. It has some level of control while providing some level of abstraction. So this is something to keep in mind. There are use cases where serverless containers may be more suitable than a serverless function. There are less and less use cases where you want to maintain your own container instances, but there are obviously cases where you want to, where you really want to have total control of what you're doing. We will move on. And I think we talked about some of the use cases for serverless. I think a sale happens, you have sudden surge. That's one case where you want to use it. The functions can be triggered by events or API calls. So the event-driven functionality is useful in certain use cases. You get some event, and then you want to react based on that event. A small change you want to do based on that event, then usually the serverless functions is helpful. Very lightweight. You just write a function, you deploy it, and it runs. You can accomplish what you want to do. And there are machine learning models you can invoke in a personalization use case, in an order processing use case. So order processing is usually an orchestration as opposed to a single atomic execution. And these event-driven functions can be orchestrated to perform an entire order processing. Order processing would involve, I don't know, validating the order placed, checking the inventory, reserving the inventory, doing fraud checks, doing payments, and then eventually shipping. So order processing is pretty complex in an e-commerce setting. And so talking about workflows, we'll see two patterns of implementing workflows, event-driven workflows. These are, you have a few microservices, one emits some event, and then anyone can listen to it, any service can listen to it, and then the interested parties listen to that event, and then they react and do something. Let's say a customer places an order, and then you have a service for sending out order updates, right? The systems that process the order can send out events, and then the services that send, the services that communicate with customers through email or text messages, whatever, they can listen to those events and then send notifications to the customer. These are some of the use cases where event-driven workflows are helpful. Because the system that is processing an order does not really care how many systems are listening to that event and reacting. It's up to those systems to listen and react, and order processing does not have to worry about it. It just have to emit an event and then move on. So there are some use cases where this is useful. There is no orchestrator here. There's no single system that orchestrates everything. This is just more fluid and helps build workflows in an organic way, but there are obviously downsides to it. The downsides are you don't have a central monitoring of the end-to-end workflow, because workflows are, as I mentioned, this is use case where one system wants to send out some event and doesn't really care what happens, who listens to it, and what they do with it. So yeah, there are the central monitoring and observability will not be here, because what system listens and what it does is there's no central authority here, but pretty useful in certain use cases. The other ways workflows usually written are orchestrated. These are carefully written sequence of steps, and this is usually controlled by a central orchestrator. And the orchestrator decides what step happens when. Each step could be a microservice, a call to a microservice. This is useful if you want to orchestrate a specific set of steps, a predefined set of steps, and you have more control here. You have error handling. The orchestrator will know if something is failing, and it can retry. It can decide to fall back. It can decide to skip. It can decide to fail the entire processing. You have much more error handling here, and this is usually used for very complex business logics. As I mentioned, e-commerce is one of the most complex business use cases out there, and there are many functionalities that are implemented as orchestrated workflows. Yeah, and we'll move to the next topic. Sub-second performance at scale. As I mentioned, there are services in Azure that will help achieve this. Azure Functions is one of them, and with premium plans, you get rapid start times. So a cold start is one of the common challenges with serverless functions, because based on traffic, it spins up or writes down instances, or rather functions. Every time a function starts, there is a time there is some time it takes to get up to speed and be able to take traffic. At the end of the day, everything is virtual machines. These are usually very specialized virtual machines very specialized virtual machines that have very minimal cold time starts, but still there is always cold time. It's not zero. So one of the usual mitigation is that pre-warmed instances. Even if you need only 10 functions instances, you keep 12 function instances running. So that when there is additional load, you have two always running that can take the load. Pre-warmed instances slightly expensive because you're basically keeping some idle. But if you really want a sub-second performance, that would be one way to do it. There are a few services in Azure that you can take a look at. I'll not go too much detail into too much details. Azure Container Apps is the serverless containers that I talked about, and Azure Functions is serverless functions. And then there is API Gateway, Azure API Management, and then there is Cosmos DB for NoSQL, for NoSQL use cases, and then Azure Service Bus. This is what you would use for sending asynchronous events or messages between services for workflows, and Azure Monitor and App Insights. So monitoring becomes one of the important areas where you would want to invest because of microservices. What happens is that you end up with so many services that talk to each other. It gets very difficult to get a high-level view of what's going on, what is performing, what is not performing, what are the issues happening in different services, and how one service creating a performance issue in the entire set of services, because everything is interconnected. There could be one service slowing down due to whatever reason, and then that has cascading impact throughout your ecosystem. And monitoring and insights is very important to detect it on time and mitigate it. And this is very critical area for everybody, all enterprises to invest in. We'll talk about some of the fault tolerance and resilience patterns. I think so far we talked about some of the architectural patterns, workflows and stuff. So now we'll talk about some of the fault tolerance patterns. So one of the things when you have so many services is that you have more flexibility in terms of how you want to handle failures. One of the patterns to handle failures is circuit breakers. And you have one service calling another service. And if service A is calling B, and let's say B is having performance issues, B is taking longer to respond, or maybe it's not responding, throwing errors. So there's no point A continuing to bombard B with requests at that point. There are many cases where slowing down requests or stopping requests helps B recover. There are specific failure modes where a service will not be able to recover if it continues to get requests. So these cases is where circuit breaker is a pattern used, where A calls B, and whenever it observes errors, A stops calling B. And A starts to return error to the caller without calling B. And this helps B recover from performance issues. And after some time, A can start calling B again and see if it works. And if it doesn't work, then again, it can break the circuit and stop calling B for some time. And it can keep trying. This helps a lot. But again, all of these patterns need to be used carefully. There are cases where circuit breakers will create issues. So let's say A is calling B, and A is thousands of instances. It's a service that has thousands of instances running. And if you stop for 5 minutes, if B is down, let's say, and A stops for 5 minutes and then starts again 5 minutes, it stops, again starts again to see if B is up. This creates a storm of requests B in a particular interval. In a really, really large system, even if you add enough jitter in how long it waits, it can get into a frequency where A bombards B with so many requests, and B struggles to recover from the degradation it is facing. So there are cases where circuit breakers may not be good. There are more intelligent ways to handle it. I will not go into the details, but there are techniques where additive increase, multiplicative decrease, and there are few other techniques people can do to help systems recover. And the other pattern is retry policies. When A calls B, if B is failing, A can retry, and but usually exponential backoff helps, where first time you retry in 1 second, second time you retry after 5 seconds, the third time you retry after 15 seconds, for example, right? This gives enough time for B to recover in case of any performance issues, especially transient issues. Again, there are cases, when we talk about very complex interconnected services in an enterprise, there are cases where this will not work as well. There are specific failure patterns where this can backfire. For example, say service A calls B and B calls C, and B is retrying whenever C fails and A is retrying whenever B fails. What this means is that when A calls B and B calls C, if C is failing, B can retry 3 times, let's say, right? It retries 3 times and then responds back to A that, eventually it failed. Now A retries again, which makes a call to B, and now B calls C and B keeps retrying. So in this pattern, let's say A retries 3 times and B retries 3 times. Then every call from A results in 3 calls to C. And as you can imagine, in a large chain of services, if you have 10, if the first one retries, the last one will get hundreds of requests for 1 call in the top of the services in the chain. The one at the bottom of the chain receives hundreds of calls if it fails. So this can create retry storm, can trigger cascading failures. C fails and B fails and eventually A fails. And so retries need to be used very judiciously. There are very specific cases where you want to use. You don't want to just go ahead and put retry everywhere. And I think it previously talked about health monitoring. So you monitor your services, CPU, memory, and any kind of signals that will tell you that service is not performing well. And you monitor and set up automatic alarm. And when it fires, you go and mitigate. Mitigation could be, manually scaling it, or maybe some fixing a bug, or any of those. And health monitoring is very important. So now we'll move on to cost optimization. Choosing right size resources is important. I think I also previously talked about how serverless functions could be slightly expensive than operating infrastructure by yourself. but it is also important to look at the entire cost of it, not just what it takes to run the hardware, but also other operational expenses and opportunity cost and everything. And choosing the right size resources helps you, and right kind of infrastructure helps you as well. And there are cloud providers that provide reserved capacity. Azure provides it. You reserve X number of capacity in advance and you get better cost. And similarly, there are Spot instances provided by Azure and a few other cloud providers as well. These are not guaranteed instances, but you can use these for non-critical use cases, something you can wait, right? So these Spot instances are usually, much cheaper than the regular. And I think auto scaling definitely helps when there is not much traffic. You want to scale it down. When there is traffic, you want to scale it up. So it's important to understand what is the metric that would indicate higher traffic versus lower traffic, or higher load versus lower traffic, lower load. It may be number of requests. In some cases, it may not be number of requests. It can be the CPU usage, or it can be a memory usage. It can be a number of events. So it's important to find out what is this dimension along which your service scales, and then use that for auto scaling your services. I think we have reached the end of the topic today. Some of the key takeaways: microservices enable agility, but as you know, it comes with its own cost. You need robust observability. And because you have a lot of services and there are few failure patterns that you need to take care of, there are other complexities that you need to worry about. It's not entirely, it's not completely hands-off. You cannot just break down a monolith and then say it's going to be good. It is not. There are a few things that you need to take care of. Serverless reduces cost. We talked about the scenarios where it can be helpful, and we also talked about how to, optimize for cost. And we touched upon some of the Azure offerings, and we talked about auto scaling, how auto scaling helps. Okay, I think that's it. Thanks everyone. If you have any questions, you can send it to me. Thank you.
Thank you so much, Naveen. It was an excellent presentation.
Hey,
Very interesting theme. I will definitely watch it again. I don't think there are any questions right now, but I know our viewers are coming. We are streaming live, but also the session is there, so our viewers will return and see it. I will send you the link, and I will share with you your badge for our talk. And if you need views, how many views we got, when you need them, just let me know, and I will send them to you.
Sure. Yeah. Thank you so much.
Thank you, Lavim,
Thank you
and
so much for the opportunity. Yeah.
I hope I'll see you again in another event. It has been a pleasure.
Sure.
Have a great one.
Same. Yeah. Thank you. Bye.
Bye bye. Bye bye. So yeah, that's it for today, and that's it for the whole of our sessions. It has been 4 wonderful days with 8. Let me see how many speakers were at the end of the day, because some of them didn't manage to come. So let me see. We got 3 speakers in our first day, 3 speakers in our second day, 2 speakers in Wednesday, and today, Friday, we had 3 speakers, 3.5, including me, for that, small, quick presentation on Fabric. So let me play a small intermission, and I will be right back with you for the closing. Thank you very much. Yes, and this is our final goodbye. I want to thank everyone for being live into our sessions, but also everyone that comes and connects and watches the sessions on their own time. You know, in our community, every video is recorded and stays on our YouTube channel. I would appreciate everyone if you could just register into our community so we can show that we do have memberships, and they are for free, of course. But I'd love to see growth. I would love to see people coming in and joining and registering and getting into our community, participating, and of course, taking the lead. I will mention once more, I do it almost every time, but I'm actively looking for speakers. So you don't have to wait for a call for speakers requests. You can contact me through our meetup group or through my other channels. You know who I am, cloudblogger.eu, um, Azure Innovators Hub in Meetup, Global AI Athens, and our Greek MVP community also. But the Greek MVP community is mostly um, for the group of the MVPs. The other channels I mentioned are for Azure Innovators and Cloud Bloggers. So please think of a session. I can help you also bring into life, and I can help you with the delivery. We can be co-hosts or co-presenters. Um, the reason I'm asking is that I would really like to see people that are just starting into their speaking uh, career, let's say, to just get some expertise, some experience, to say it better, through our small group. This could be amazingly helpful for your speech deliveries. You will get some exercise, let's say. You will get some expertise, of course, and some type of mentorship. I could be there for you, make suggestions, and help you deliver it. So don't hesitate. Feel free to contact me for any speech you would like to deliver around cloud, Azure, AI, DevOps, and Microsoft 365 technologies. I'm also open to other speeches talks, but if it is outside of these areas that I just described, we need to discuss it. Okay. Our group is named Azure Innovators Hub. So you can imagine we are looking into Microsoft stack mostly, and we are open uh, to showcase other technologies as well in relation to Azure and 365, to DevOps, a lot of integration capabilities and possibilities that we can use in our speech. So enough about this. Thank you everyone for being here. Azure AI Connect is coming on March, and this is the first public announcement. So stay tuned. A lot of amazing speakers. I won't spoil the news, but I have already um, an amazing lineup for our March 5 days event, and I hope the developers community Talimandu will be able to once more join and do this together. Have a great weekend, everyone. Bye bye.